Today's video is on section 10.4, which is ellipses, graphing and writing equations. The definition of an ellipse is a set of points in the plane, the sum of whose distances from two fixed points, called foci, is a constant. An ellipse looks kind of like this. We can either have a long ellipse that's on the horizontal axis, longer on the horizontal axis, or one that is longer on the vertical axis. And we're going to look at graphing those with specific points. Now in an ellipse, if you look down below the graph, the things we're asking you to identify and graph are the center, vertices, which are the endpoints of the longer axis of symmetry, and the co-vertices, which are on the shorter axis, and then foci, which are those 2 points that are fixed that we talked about in the definition. So when we have an equation of an ellipse, it looks like this given to you on your notes. We can have x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. The sum will always be equal to 1. You will have an a squared and a b squared. If the major axis is on the horizontal, the a squared, or the major axis, will be under the x. The bigger number will be under the x. And if it's a bigger number under the y, then the major axis is on the vertical. And we'll see examples of each of these. So our first example is x squared over 9 plus y squared over 4 equals 1. So first of all, we want to identify our center. Our center is at HK, so if we just write on top the x minus h and y minus k quantity squared, notice there is no h and k, so our center is at 0, 0. So let's move down and write in our center of 0, 0. Let's plot that on our graph at the origin. If we go back up and look at our equation, we then can identify our a squared and b squared. So for this example, a squared is 9. That means that the distance from the center to a major vertex, or to our vertices, is the square root of 9, or 3. Now the distance from the center going in the positive direction and also going in the negative direction gives us our length of our major vertex. So from our center, we go 3 to the right and draw a point, and 3 to the left and draw another vertex, and we have the endpoints of our major axis. We can then write the coordinates of those points in our spot below our graph. So the vertices are at 3, 0 and at negative 3, 0. Now we want to find the vertices that are called co-vertices, the endpoints of our minor axes. So we look at b squared, which is equal to 4. So the distance b is 2. Now that means we're going to go plus 2 in the y direction, positive y direction, and draw a point, and down 2 in the y direction and draw our other co-vertex. So then let's move down and write those in the space provided. So our co-vertices are at 0, 2, and at 0, negative 2. We can now sketch in our ellipse, and we see the longer axis, the major axis, is on the horizontal, and the shorter minor axis is on the vertical. We now need to find the foci, and you see on your note sheet that in order to find the foci, over here on the right, we use c squared equals a squared minus b squared. The distance c is from the center to a foci. So for this example, c squared equals 9 minus 4. So c squared equals 5. So c equals the square root of 5. Now that's the distance again from the center to our foci. So we approximate a little bit. Square root of 5 is just a little bit bigger than the square root of 4, which is 2. So on our graph, we make that a little bit bigger. On our graph, we go to just a little bit over the square root of 2, and we can draw our foci. Now I'm going to draw them in a different color so you can see where they appear. And then again to the left. The foci always appear on the major axes, and now we can write our coordinates of our foci in the blank provided. So the coordinates of the foci are at square root of 5, comma 0, and negative square root of 5, comma 0. Notice in general that when the larger number in the denominator is under the x squared, our vertices are at the point h plus a, comma k, and h minus a, comma k. Our co-vertices, the k value will change. So our co-vertices would be at h and k plus b and h, k minus b. Our foci, we'll go back to red, our foci, we add c to our h value, comma k, and we subtract c from our h value, comma k. So in general, we can use those formulas, or we can simply find the distance and then count on our graph. So let's go to our next page and look at example 2. So now we need to find the vertices. we're always going to say that the major axis is A, so we're going to look at A squared equals 25, so A equals 5. So from our center, we go up 5 to the point negative 2, 6, and down 5 to the point negative 2, negative 4. So then we can write our vertices here at negative 2, 6 and negative 2, negative 4. Our co-vertices are at b squared using the b, the minor axis, so that equals 4, so therefore b equals 2. So our minor axes endpoints are 2 to the right and 2 to the left. So the coordinates of our co-vertices are at 0, 1, and negative 4, 1. We can now sketch in our ellipse. Notice it's taller on the y-axis versus on the horizontal as example 1. We now need to find our foci, so let's go down a little bit. The foci, because we're using A always as the major axis, is c squared equals a squared minus b squared. C squared will then equal 25 minus 4, which equals 21. So c equals the square root of 21. Again, we need to approximate that value. Square root of 21 is almost right in the middle of the square root of 16 and square root of 25, which is almost right in the middle of 4 and 5. So when we graph this, we go back up to our grid, and we can graph the distance again is somewhere between 4 and 5. So 1, 2, 3, 4 and a half. And then same in the other direction. Sometimes the foci are very close to the vertices in this case. Sometimes they're a little farther away. You will notice that as the size of the ellipse changes. So here's the graph. We now need to go down and write the coordinates for our foci. So the coordinates for our foci are negative 2, and then 1 plus the square root of 21, and our other point is negative 2, and 1 minus the square root of 21. In general, again, since our major axis is in the y direction, we can write the general foci as hk plus c and hk minus c. If this is helpful for you, then you can use that formula versus sketching them on the graph. So now it's your turn to try example 3. So if we look at example 3, remember which direction the major and minor axes will be, and identify center vertices, co-vertices, and foci, and then we'll come back and check to see how you did. So hopefully you were able to find a center of 0, 0. Then you found vertices, since the larger denominator was under the x squared. The major axis was in the x direction, so you found vertices of 7, 0 and negative 7, 0. So we'll plot those. And then you found co-vertices of 0, 5 and 0, negative 5. So so b equals 5. Then you could sketch your ellipse. Missed a little bit. Let's go back and try that again. It's a little bit better. So then we want to make sure we have the points written for the coordinates of our co-vertices as well. So our co-vertices are at 0, 5 and 0, negative 5. Our foci then, you get c squared equals the square root of 24. We need to make sure we simplify that. So c squared is the square root of 24, which equals 2 square root of 6. So our foci are at 2 square root of 6, comma 0. There shouldn't be a comma in there. Just 2 times square root of 6, comma 0. And then the other foci is at negative 2 square root of 6, comma 0. Again, square root of 24 is really close to the square root of 25. So the distance from our center to our foci is going to be just a little under 5. So I'm going to put those in red again so you can see where the foci will be on the graph. So hopefully you were able to draw and identify all those pieces for the ellipse. Remember again that you have two different types of ellipses, one that is longer on the horizontal axis, like examples 1 and 3, one that is longer on the vertical axis, like example 2. Look at the general pieces of information. So the foci, when the vertical axis is the major axis, notice we're adding and subtracting from the k or y value, as well as when we draw the vertices. And on the horizontal, where the major axis is on the horizontal, we would add or subtract from the h value. If you have questions, as always, ask your teacher in class, and have a great day.